Here we go. This is this review's on the second PowerPoint, which was more involved than the first one. We finish up the anatomy of the eye here, discussing the two compartments of the eye, the anterior compartment and the posterior compartment. These are separated by the lens. The posterior compartment is filled with a viscous gel-like fluid called vitreous humor. The vitreous humor, somewhat like air blowing up a balloon, supports the eye in general. So it supports the lens towards the front of that compartment, and it presses the retina firmly on the rear of the compartment there. The anterior compartment is filled with a more watery fluid, thus termed aqueous humor. This, I said, functions somewhat like tears and removes wastes from the front of the lens. This is constantly produced and drains via a opening there called the canal of Schlemm. If too much aqueous humor is produced, or if the canal doesn't drain properly, you get a buildup of pressure in this compartment, and that pressure can lead to glaucoma, which can damage the retina and some of the delicate structures of the eye. So you can see, if you follow the arrows here, how the aqueous humor is produced, washes across the front of the lens, and drains via this canal. Speaking of the anatomy, you get a really good look here of some of the things you might have to label on a diagram: the lens, the suspensory ligaments, and the ciliary body, for example. Alright, in between these two compartments is your lens. This is a biconvex lens versus a concave lens, which would be shaped more like an hourglass. This lens is flexible. We know it changes shape. And down here we discussed how as you get older, the lens gets more opaque, not as transparent, and not as flexible. And this dysfunction is termed cataracts. And they can replace with surgery your lens with an artificial one. The rest of the PowerPoint is on how this lens acts in vision. We discussed this, how the image that's on your retina is upside down and reverse, and then your brain flips it right side up so that you do see the world the way it is, shown in this slide here. And again, this is your basic physics. The pathway of light was stressed. When light enters the eye, it strikes the cornea, the aqueous humor, the lens, and the vitreous humor in that order. And these are all areas where the light is potentially refracted. Alright, this was important. Some of the changes here, when you're looking at something far away, the object is small, so we want the light rays to go straight into the eye and onto the retina. So we want your lens to be flat, and we said to act like a pane of glass, and to just allow the light through without refracting it too much. If the lens is flat, we're going to want to tug on that lens and stretch it out and make it nice and flat. So we want our ligaments, our suspensory ligaments, to be tight. And then again, opposite of what you might think, for the ligaments to be tight, the ciliary muscle or ciliary body is going to be relaxed. I use the analogy of exhaling. As the muscle exhales, if you will, or relaxes, it opens up, which pulls the ligaments tightly. This term came up in some of our worksheets. Accommodation is how that lens changes shape, becomes more round, increasing its refractory ability to compress a large object that is right in front of your eyes and compress that image onto your retina. So here we go for close vision. We want the lens bulging, so we want that lens round. To get that lens round, we want the ligaments to be loose. If the ligament's loose, we want the muscle to contract. So please remember those differences. Nearsighted versus farsighted. Remember, the emmetropic eye is a normal eye, and when we say normal, we mean that the image is focused properly on the retina, not in front, not behind, but on it. In nearsighted or farsightedness, the image is not on the retina. And nearsighted, in which you can see near and have trouble seeing far, the image is in front of the retina. So since the image is in front of the retina, what we want to do with a lens like an eyeglass or a contact lens is push the image back. And you're going to do that with an eyeglass that's not like your eye. We want a concave lens, which will force the light rays to diverge, pushing the image further back. If you're farsighted, then you see far well, but you have trouble seeing near. The focus point of your image is not in front of the retina, but is far. It's behind the retina. And what we want to do is we want to pull the image up. And to do that, we want a lens similar to your lens, a nice big beefy round lens that's going to compress that image, converge the light rays, and bring that image, or maybe pull up is not the best word. I'll stick with pull up, but what we want to do is we want to squeeze it more quickly to fit it onto the retina. So in nearsighted, that image is in front of your retina because your eyeball is too long. So again, we want to push it back, and we're going to do that with a concave lens. In farsightedness, your eyeball is too short. The image is behind the retina, we want to pull it up, and we're going to do that with a convex lens. Hard stuff, a little bit more on rods and cones. Again, rods are more sensitive because they don't need a lot of light to wake up. When they wake up, they see, but only in gray tones. They don't see color very well. Also, the image is not particularly detailed, which is why we don't see well at night. And the reason for that is many rods feed into a single ganglion cell on its way to the optic nerve. Conversely, a cone is not very sensitive. In order to wake up, so to speak, it needs a lot of stimulation, a lot of light. When it does that, we see in color and very well, and that's because each cone has its own ganglion cell. We discussed glaucoma and cataracts. In the first PowerPoint, conjunctivitis was mentioned. Here, another eye disorder mentioned, which is color blindness. You have three types of cones. When one of these is not working, usually due to some type of genetic condition, we term that color blindness. And usually in color blindness, it's two colors that are not distinguished. It's not completely a black and white view. Good luck.